Hello there, Mr. Sutton here, bringing you the IM3 1.2 Extra Practice Number 2 solutions on solving systems using the substitution method. And for this one, we're going to solve the following puzzle. Let me bring it up for you. So this puzzle right here, we're given a bunch of equations, systems of equations that we need to solve using the substitution method if we so choose. And then we have to find the solution in the answer column that's next to these, and take a look at the two letters next to whatever the answer is and put those two letters in the number spaces below that go with the problem we just did. And we're ultimately trying to solve the riddle, why does the president put vegetables in his blender? Let's give it a go. For our opening problem, we have these two equations. We've got y all by itself here, so I can use the substitution method to replace the y in the second equation with this 2x that y equals in the first equation. So if I do that, I've got x plus 2x after I plug that in equals 12. So I can now combine these to get 3x equals 12. And then dividing by 3, I see that x equals 4. All right, let me go ahead and plug 4 back into one of these equations to find y. I'll use this first equation. It looks pretty easy. So we've got y equals 2 times 4, which means y equals 8. And then my final answer, writing this in point form, is going to be 4, 8. Now, looking at this column of answers, I see that I've got 4, 8 next to HE. So since this was problem 1, I'm going to go down to these ones here and write in HE, and then I can go on to problem 2. For this problem, I notice that I've got x all by itself here. So I can take the stuff that x represents, 3y minus 1, and replace the x in the other equation here with 3y minus 1. So let's go ahead and do that. I'll use a parentheses to show what I just did. So I've got 3y minus 1 plus 2y equals 9. I can now combine like terms. 3y and 2y, that's going to give me 5y. I still have that minus 1 over there. Adding that to the other side, now we've got 10. And then dividing both sides by 5, we have y equals 2. We can replace y with 2 now back in this equation up here. You could use either equation, but this one's already got x by itself. So this is going to be x equals 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is going to give me 5. So overall then, that's the point 5, 2. And just looking at my list of answers here, 5, 2 is down at the bottom. It's IS, so I'm going to put an I and an S in the spot for problem 2. On this problem, I notice that I've got y all by itself in this equation on the left, so I can replace y with 2x minus 5 over in this equation here on the right. I'm going to use parentheses to make sure I don't lose anything, so I've got 4x minus, and now in a parentheses, 2x minus 5. So the only thing we did was swapped that out. And that all equals 7. Now that I've got all x's over here, I can combine like terms and move things around a little bit. So 4x minus 2x is going to be, well actually let's distribute this first so I don't make any silly mistakes. So this will be a minus 2x, and minus minus gives me a plus 5. So now combining like terms, 4x minus 2x gives us 2x, and I can subtract 5 over to the other side of the equation. 7 minus 5 gives me a 2 over there. Dividing both sides by 2, that's pretty convenient. We have x equals 1. And now I can replace x with 1 over in this equation we started with. So this is going to be y equals 2 times 1 minus 5. So that's just 2 minus 5, or negative 3. And I should actually have y equals over there. Let me change that. There we go. It was a y the whole time, right? So that gives us the overall point 1, negative 3. And looking that up in my answers, I've got h and o. So that's what I'll put in my 3 spots, h and o. And this is starting to come together into something, I guess. He is, and beyond that, we don't know. We have to keep going. For this next problem, we've got nothing isolated in the first equation. However, in the second equation now, we've got x all by itself, which is kind of nice. So I'm going to take x over in this first equation, and I'm going to replace it with 4y plus 1 from my second equation, because we have x equaling all that stuff. I've got to be careful when I do this and use parentheses. So I'm going to have 2 parentheses, 4y plus 1. And then we still have a minus 3 there. We still have the equals 12. So this is the only thing we changed, is swapping that out. Distributing now, I've got 8y plus 2, if I distribute that 2. And then we still have a minus 3 and an equals 12. Combining like terms, 8y minus 3, that's going to be 5y. Still have that 2 over on the left side, but we're going to take care of that now. Move it over to the right side. 12 minus 2 gives us 10. And then dividing both sides by 5, we've got y equals 2. Now that I know what y is, I can plug that back in and find the value of x from this second equation that we had over here. So plugging 2 in for this y, we've got x equals 4 times 2 plus 1. So that's 8 plus 1, which comes out to 9. So overall, my point then is going to be 9, 2. And looking that up over here in my answers, I've got a 9, 2 right here next to the pi. So that's what I'll put in spot 4, p and I. For this problem, I noticed that I've got this y all by itself in the first equation. So I can replace y with negative x plus 5 over here in the second equation. So for the second one, I'll write x minus 4, and now let me use a parentheses to plug in this negative x plus 5. And that still equals 10. I better distribute now. So this x stays the same, but now I've got negative 4 times negative x, that's positive 4x. And then negative 4 times 5, that's negative 20. And we still have the 10 over there. Combining like terms, I've got a 5x. And if I add the 20 over there, I end up with 30. So 5x equals 30. That means that x is going to be 30 divided by 5, or 6, which I can now replace the x up here with. So we'll have negative 6 plus 5 equals y. So that's going to be negative 1 for my y value, giving me an overall point of 6, negative 1. And then that looks like, let's see, this answer right here. So NG goes in the 5 spots. So if you've been looking for more of a challenge up to now, you finally got it. This is the first question where they did not give us at least one equation where one of the variables was isolated. So looking at both of these equations, we need to figure out which variable we want to get by itself in which equation, at least if we're going to use substitution method. So I think the first equation here is going to be a little bit easier to work with because the x and the y here don't have coefficients other than 1 or negative 1. And between the two variables, I think x is going to be a little easier to get by itself because all I need to do is just add y to the other side. So I can rewrite this first equation, and this will be my first step, as x equals y plus 2, or 2 plus y, either way. Now that I've got x by itself, I can replace x over here with this y plus 2 that x equals. So I can rewrite this over here as 4 parentheses y plus 2 minus 3y equals 11. Distributing my 4, I've got 4y plus 4 times 2 is 8, and I still have all this other stuff that hasn't changed yet in that equation. Now let me combine like terms. 4y minus 3y, that's going to give me 1y. Still have an 8 over there. And conveniently, to get y, I just have to subtract 8. So we have y equals 3. So that gives me something I can plug in for y back in this equation up here. I could use either of these starting equations too, but it's going to be a little faster if I use this one because x is already by itself. So plugging 3 in right here, I've got x equals 3 plus 2, which means x equals 5. So means I have the point 5, 3 for my final answer. And looking that up in my answer choices, that goes with this FO right here. So in spot 6, I will write F and O. For this problem, if I want to solve this using substitution, I'm going to have to first get one of the variables all by itself. Taking a look at my options here, I'm thinking this x in the second equation is going to be a lot easier to isolate because it has no coefficient other than the invisible 1. So let me start this off by subtracting this 2y from both sides over here just to get this x by itself. So I'm going to have 7 minus 2y, or negative 2y plus 7, either way. Now I can replace this x in the other equation with the stuff that x equals, the 7 minus 2y. So over in this equation now, I can write negative 2 parentheses 7 minus 2y, and that's the only change. I'm still going to have my plus 3y and my 14. Now I have to distribute to get this y out of the parentheses. So I've got negative 2 times 7 is negative 14. Negative 2 times negative 2y, that's going to be positive 4y. And I still have a 3y, and I still have a 14. Combining like terms, 4y plus 3y gives me 7y. And now to get the 7y by itself, next I'm going to add 14 over here. 14 plus 14 is 28. And now dividing both sides by 7 to get y by itself, we've got y equals 4. All right, now that I found y, I can plug that 4 back in for y in this equation right here. There's a few others I could have used, but this seems to be the easiest way to do it. So I've got 7 minus 2 times 4 equaling x. So this is 7 minus 8, which is negative 1. So then I have the answer negative 1 comma 4 for this one. And looking that up, it looks like I've got an RW next to negative 1 comma 4 in my table. So I'm going to write RW in my 7 spot. For this problem, I need to try solving this by substitution, but I can't do that unless I have a variable all by itself. So taking a look at good ones to get by themselves, I'm thinking this y right here, this negative y, is going to be my best bet, because all these other variables I'm going to have to at some point divide by something like a 2 or a 6. With this negative y, at some point I'll have to multiply by negative 1, but that's it after I've got it by itself. So to start this process, let me first get this 6x moved over to the other side by subtracting it. So this will be negative 6x minus 4 over here. And on the left side now, all that's left is a negative y. For my next step, I'm going to multiply or divide, either way, all of this equation by negative 1. So that'll give me positive y, positive 6x, and positive 4 if I divide all those by negative 1. Now that I have y truly by itself, I can go ahead and replace this y with 6x plus 4 over here in this second equation. So this will be 2x plus 2 parentheses 6x plus 4 equals 15. And I can distribute this 2 to the parentheses. So I've got a 12x right there and an 8. Still have the equals 15. 2x plus 12x, combining like terms, gives me 14x. And if I subtract 8 from both sides, 15 minus 8 is 7. So be careful here. We have to divide by 14, not 7, because we're trying to get x by itself. So x is going to be 7 over 14, which I can reduce to 1 over 2. So this is my answer that I'm going to now plug in for x to get a y value. And I'm going to use this equation right here. I took a little bit of trouble to rearrange things this way, so I might as well use it since y is all by itself already. So I can write y equals 6 times 1/2 plus 4. And 6 times 1/2, that's basically 6 times 1 is 6, divided by 2 is 3, so 3 plus 4, which gives me 7. So I've got the point just positive 1/2 comma 7. And then looking at my answer choices, that corresponds to the HI here. So for 8, I'm going to put H and I. For this question, if I want to do this with substitution, I need to isolate one of my variables. I've actually got a lot of options in this one. I could go with the x here, or the y, or this other y over here. They all look pretty good. What I'm going to end up doing, though, I am just going to get this x in this first equation all by itself. I'm just going to subtract y over to the other side. So 1 minus y equals x. And now I can replace the x over in this second equation with this 1 minus y. So if I plug that in, I've got 2 parentheses 1 minus y, minus the y equals negative 2 still. And now if I distribute this 2, I've got 2 minus 2y, and then all that other stuff as well. And now if I combine like terms, this is going to be a negative 3y on the left side. And now I can subtract 2 to get over to the other side here. So that's going to be a negative 2 minus 2 is negative 4. And then finally, if I divide both sides by negative 3, I'll get y by itself. So I'll have negative 4 over negative 3. Since those are both negative, I can make that positive 4/3 for the y value. All right, let's go ahead and plug that back in to this equation up here so I can get an x value. Now, when I rewrite this, instead of writing x equals 1 minus 4/3, I'm going to just turn this 1 into something with a denominator of 3, a common denominator. So I can rewrite this 1 as, we'll say, 3 over 3, because that's really 1 if I divide those, right? So I have 3/3 minus 4/3. Subtracting our numerators, keeping the denominator the same, that's going to be negative 1 over 3. So that's our x value. Negative 1/3 comma 4/3 then would be our final answer. So that's going to be this RL right here. So in spots 9 and 9, let me put R and L and move on to the next one. On this one, looking around for variables that I can isolate so I can use my substitution method, I'm thinking this x in the second equation looks like a pretty good target. I can easily get this alone if I just add 2y over to the other side. So one-step isolation there. And now that I've done that, I can replace the x in the first equation with this 2y plus 2. So doing that, I've got 5 parentheses 2y plus 2. And now if I distribute that 5, 5 times 2y is 10y. 5 times 2 gives me a 10, and I still have a minus 3 and a minus 11 for the rest of that equation. Let me clean up the left side a little bit now by combining like terms. 10y minus 3y, that's going to be 7y. And now if I subtract 10 from both sides, negative 11 minus 10 gives me negative 21. And then finally, if I divide both sides by 7, we have y equals negative 3. All right, now that I've got the value of y, I can plug that negative 3 back in up here. I'll use this isolated equation, and that'll help me find the value of x. So I've got x equals 2 times negative 3 minus 2. 2 times negative 3 is negative 6, and negative 6 plus 2 is negative 4 for my x value. So then that gives me the point negative 4 comma negative 3. Looking at my answers up here, I've got a negative 4 and a negative 3 in this last one here, the ED. So in spot 10, I will put E and D. On this problem, if I want to use substitution, let me get a variable by itself. I'm thinking I should tackle one of the variables in this first equation. If I just add y to the other side here, I can get x by itself pretty quickly. So I can write x equals y plus 3, or 3 plus y. Now I can replace the x over in this the second equation rather, with the y plus 3 that we said x equals over here. So now instead of writing 6x, I can write 6 parentheses y plus 3 plus 4y equals 13. Distributing my 6 to simplify the left side, I've got 6y plus 18, and then the rest of this stuff is unchanged. Combining like terms, we've got 6y and 4y. That's going to be 10y. And then I can subtract the 18 from both sides. So 13 minus 18 is negative 5. And be careful at this point. We're dividing by 10, not negative 5. So we have y equals negative 5 over 10, which I can reduce to negative 1 over 2. This is the y value I'm going to plug back in to this isolated equation up here to get my x value. Now when I do this, I want to get a common denominator. So instead of writing a 3 here, I'm going to express this in terms of 2's. So instead of 3 over 1, I can write 6 over 2. So I'll have negative 1/2 plus 6 over 2 when I rewrite that. And then negative 1 plus 6 is 5. Keep my denominator the same. So we have positive 5 over 2 for the x value. Writing that out as a point then, we've got 5/2, comma, -1/2. And that is going to match up with, let's see, here's a 5/2, but we don't have the -1/2. So this one, I think, was just there to distract us. Down here, we have 5/2 and -1/2. So we've got a P and an E going in those 11 spots. So here I am at my last problem on this puzzle here. Again, trying to solve this using substitution. Now, if I'm trying to get any of these variables alone, there's looks like a lot of ones it would be pretty easy to do that for. This y over here and this x, but nothing I could do in a single step. So no matter what I do, I'm going to have to do this in a couple steps. I'm just going to use my first equation here. And then to get this y alone, one thing I could do is subtract the 2x from both sides. So I can write negative y equals -2x plus 16, or 16 minus 2x, doesn't really matter. But then I have to get a positive y, not a negative one. So if I multiply this whole equation by -1, I can write y equals positive 2x minus 16. Next, I can replace the y in the second equation with this 2x minus 16 expression that I just came up with. So this is going to be negative x plus 2 parentheses 2x minus 16. And then if I distribute that, I've got negative x plus 4x, and then this will be a minus 32 equals -8. Combining like terms, negative x and 4x gives me 3x. And then if I add 32 over to the other side, -8 plus 32 gives me 24. So dividing by 3, I end up with x equals 8. All right, now let me plug this back in. This equation right here where I isolated y seems like a pretty good spot. So let me put the 8 in right here for this x. So I've got y equals 2 times 8 minus 16. 2 times 8 is 16, so if I subtract 16, then y just equals 0. So then I end up with 8 comma 0 for that answer. And looking at my answers, this last one here, AS, that's what matches up with 8 comma 0. So spot 12, we have an A and an S. And in a moment, we're going to see what this all spells out. All right, so we found all the letters doing all that substitution method. The original riddle again was, why does the president put vegetables in his blender? And just trying to read this out, it looks like we have an HE, so that's a he. IS is, and HOPING, I think that's hoping I can spell out with that next one. For, and this last one is kind of weird. We have world peas. All right, so world peas. Oh, he is hoping for world peace, a play on world peas. I get it. All right, there we go.